Hello, my name is Rich Whitaker. This particular presentation is a pre-institute tutorial for the folks at the Lens Institute. You're going to be doing some field work, and as a part of that we hope you make some associations between the things that you can see on the topographic map and the materials that you're going to find at the site, the things that lead you to understand what the geologic history might be like at that location. So a brief comment then about topographic maps, and we'll take a look at several. Of course, these maps show elevations as indicated by the brown lines. There's also quite a number of cultural features and water features that you can see on these things. The key features that you're going to want to see here in the landscape are going to be the slopes, the flats, and the valleys. The steeper the slope, the more the contour lines are going to be bunched up together. They will be more concentrated in going down the hillside. The farther apart they are, the flatter or more gentle the slope will be. And where they're wide, far apart, we actually can call them flats. The other thing to notice is the pattern of the contours, particularly when you get these kinks in them that we call V's. The V's are actually formed by streams running in them during rainstorms. They may not have enough water in it to show as a blue line on the map for a long period of time, but you do have streams carving valleys here. You can trace out these V's and see why we say that, because the V's almost always run together or form lines that run together into a network pattern that essentially defines the watershed. What you will see along the hillsides, of course, is that water and sediment wash down the hillsides into the streams, and then the streams carry the sediment away. It's very important to recognize these slopes as areas of erosion tied to the stream cutting down the valley. Another effect of the streams carrying sediment is that as the streams, of course, wash down into the lower ground, as you can see here, they will end up at one time or another depositing sediment in the low spots. So the big broad flat at the bottom of the hill will typically be underlain by a deposit of stream sediments. So what we've been talking about is largely what you'll be seeing across the western portion of the state. If you take the fall zone, which is the boundary of the western edge of the coastal plain, the areas west of there almost invariably have stream carved landscapes almost everywhere. And what we've just talked about is a rule that works well out there. The principal rule again is that steep areas indicate zones of erosion. Flat areas would indicate zones of deposition. So let's see how that plays out. If you go down to the valley bottom and you're wondering what kind of material is going to be down below your feet, the best way to do that is to dig a hole. So here we have our intrepid geologist digging a hole. And the first thing they pull out of the hole would be mud, very commonly. As the geologist continues to dig, they end up finding sand farther down, usually. And then as they continue to dig, it's very, very common to hit gravel on the bottom underneath these flats. This particular package of gravel, sand, and mud going up through the package is called a fining upwards sequence. It's so common, it's given this particular sort of name. Usually down by the rivers, this sits on top of bedrock, below the gravel. Notice that this fining upward sequence package is usually about as thick or a little bit thicker than the channel is deep when the channel's at flood stage. That's because the stream has formed this package as it's moved back and forth across the river valley, as it's meandered across the floodplain. The other important thing to keep in mind about this is that it's not only the streams but the slopes acting with it. As the stream would have cut down over time, the slopes along the side of the valley will of course slough and wash. Material will creep down into the valley bottom. And as you continue to get erosion, maybe a broader floodplain of the stream channel, the slopes are also eroding back. And so when you eventually come to a big valley with a stream at the bottom, you can be quite sure that material inside of that valley has all been excavated by the stream over time. So as you are standing up on the hilltop wondering what's going to be found beneath my feet, this area of erosion could be almost anything. In fact, it's essentially whatever the rock or the sediment was before the river valley was cut. So you can't really tell much from just the topographic map about what should be out there. Perhaps you check a geologic map or a soils map. But if you go down the hill and take a look at the flat material, that is where you're going to find your finding upward sequence. So down at the bottom of the hill in the floodplain, this works well, again, in the western part of the state. In the eastern part of the state, though, we're going to be able to do a little bit better, because the rules that we have for the western part of the state, we get to modify just a bit, so that when we go to a study site, very commonly we're going to find not one flat, but two flats and a steep area. So in eastern Virginia, not only is the rule steep areas would be zones of erosion and flat areas would indicate deposits, but you also have to remember, never forget the ocean. For example, looking at a typical coastal plain landscape, the steep areas here are carved, well, on the western circle. Those clearly are slopes going down to a stream, and so those would be the typical stream slopes we just talked about. But over on the eastern side, you see some slopes that were carved by waves as they came crashing into those high hills during storms. So waves and streams can cut the steep slopes. Same sort of thing is true for the flats as well. The flats that you find down inside the valley bottoms are very clearly going to be related to deposits in those narrow stream valleys. However, we find a lot of flats up on the hilltops, the broad areas that are left as very broad marine terraces. You can't tell just from this picture, but the overall pattern we can see is that they very clearly are marine deposits. They occurred because during the Quaternary, when the glaciers have grown and retreated, every time they do this, the sea level bobs up and down accordingly. And so when the sea level actually was higher than it was at present in the past, the seas cut a notch into the side of the continent and kept eroding over until, well, eroded a cliff, as you can see here, and it also left a carpet of sediments lying on top of the older sediments that it was eroding across. So during high sea level stands, as the transgression and regression, as we say, of the ocean came in and out, it left behind a carpet of gravel on the bottom, sand above that, and a layer of mud across the top. That would extend inland to the point then where you would encounter a scarp, a wave-cut cliff that had been eroded into those older sediments. Now typically these sediments might be 30 feet thick, 6 to 10 meters, and perhaps as much as 100 kilometers wide. So these can be very, very big, broad deposits spread across the landscape. So we just expect that when we come to a coastal plain setting, very typically those upper flats are going to be made out of different material than the lower flats. And the steep slope that separates the two flats, the two deposits, has a very important role to play in understanding history. We expect that those upper flats are going to be a stack of sediments, gravel with sand over that and mud over that. And then as sea level would have dropped from that high stand, going down to lower level, you're going to see a lot of deep erosion by streams in many places. As the sea level would rise then, with the next deglaciation, you'd find water filling the valleys like they do now, and sediments filling into those estuaries, and eventually in some places completely filling the valley with muds and peats. And so you are left with this landscape then of two flats, two bottoms, two bottomlands, and the intervening slope in between, which is essentially the partially buried sides of the filled valley. So you can see the geologic history then sorted out here, and the difference that you find in the materials in the lower flat versus the upper flat can be quite dramatic. So the general rule then for eastern Virginia is that steep areas indeed are erosional. Usually they're cut by streams, but it's also possible they are cut by waves. The flat areas, the deposits, you can find them under the hilltops as well as the valley bottoms, and the ones under the hilltops would have been left by waves. The ones down at the valley bottoms would have been left by streams. So, just a little word to the wise so that anytime you're out doing field work, you can understand better what you're getting into.